Hey everybody, welcome back to the shop for another week of SNS. So it's been kind of a weird week for me this week. I've been under the weather and I'm still not 100%. I come down with just some kind of virus illness Monday evening, and it took me down. I had to miss work for about a day and a half this week. Just took all my energy away from me, and man, it was rough. But I'm getting better now. I think I'm finally on the mend, and I'm getting better. I'm still not 100%, but I am getting better. But just been a weird week for me. I had to take some time off work and rest, and that's what I did. Even that half day, I had to come home and just rest. I had no energy at all. That virus that I had was pretty rough. But anyway, I'm glad to be getting over that. But on top of that, I've been kind of upset about the progress of the enclosure that's been going on. I figured I'd go ahead and give you guys an update this week and show you what has been done out there. But just dealing with construction, I'm hearing it from a lot of other people that it's a common theme in construction is delay after delay, and it seems like that's what I'm having to deal with too. It started off with rain delays whenever it first started, because we'd get bad rainstorms every single day, and it was like delays with materials, like the metal being cut to length and that kind of stuff, and then just other materials. And then the guy that's doing the work got sick last weekend, and he's been out all week, and he told me it would be another week before he got back. So it's about 2 weeks behind schedule now. So I'm trying to just not stress out about it and just let it go, and hopefully it'll be done when it's done. So I'll just give you guys a quick peek at it and show you, the wall's gone up and that kind of stuff. So we'll go out there and take a look at it and see where we go, and hopefully in another week there'll be more progress, better progress, and I'll be able to show you some more things. But I'm still very excited to get this enclosure finished and get that chapter done and move on to the next one and start getting things done out there that I need to do in preparations for moving some of the equipment out there to get started on, as that being a work area out there. I wanted to go ahead and again thank everybody that's been supporting me through their Patreon, and then we've had a couple guys here recently, this week, want to send over some contributions through PayPal, and totally their thing. They asked for it, and so I gave them the PayPal info, and I just want to thank all you guys that's been doing that, and that will all go towards the enclosure project. And then there's plenty after that we're going to do. The next two phases, probably the next immediate phase after that's done and that guy's work is done, is having an electrician come in and do my 3-phase power out there and get the power run to the machines that I'm going to put out there, which the press is already out there. I want to put the pedestal grinder out there, and there's something else, I can't think of it right now, but there's going to be a few 3-phase machines out there. And as far as some of your concerns about the air compressor, this guy that's doing this work here is going to stub out a location for wiring to go out there for the air compressor. So that'll be done. And then whenever I want to have concrete done in front of the shop here, a nice slab out there in front of the shop that connects both sections of the shop and have a working area out front. Once that is done, whenever that is done at the same time, I'd like to have a small equipment pad poured in the back corner that the air compressor will go on, and then I'll build a cover over that, another little lean-to, just to keep the rain off of the air compressor, and then that'll get moved out there, and then it'll be hooked back up. So that was my plan for the air compressor, to do that. So I think that's about what I wanted to mention about that, and give everybody thanks for the continued support. All those dollars are going towards that project out there, and I really appreciate the help. It has been a tremendous help from me. So I've got some machine work that I'm going to share with you this week. We've already done. I got a new job in the shop right there that I've been working on. Got a couple gears. We got to put a tapered bore in there, and I've also got to make a broach plug for it also. So we're going to do some tapered turning on that piece of stock right there, and then I got to do some milling. I believe I'm going to set up the K&T here to do some horizontal milling. So that's going to be coming real soon, maybe next week or so. You know, we'll have some footage of that. All right. I got one little viewer gift that's come in right here that I wanted to show you, and in the latest series with the LeBlanc lathe crossfeed nut, I was using the gauge pins, and I'd mentioned that the one that was missing was the 800 gauge pin. Well, a viewer sent me one. This is the 800 minus, so it's supposed to be 2/10 under 800 thousandths, and very nice, made by Mayer, the Mayer gauge. And this was sent to me by Joseph Touchier. I'm not really sure how to pronounce his last name there. And he's from Mentor, Ohio. And I remember seeing the comment that he was going to have one coming in the mail here. So thank you, Joseph. We got a nice 800 gauge. This one looks to be in great shape, and they're supposed to be heat treated, so they're hardened and then ground to size, unlike the other ones that are soft. So we got us a nice 800 gauge to fill up the set over there. All right, for all you guys that wanted the update this week, here's your update. There's not a whole lot more to share with you, but this is what's been done since a couple weeks ago. So the wall was studded in, OSB board was put up, and then it was wrapped there with the was that Tyvek, I believe. And the plumbing was run. There's a spigot right there, and it runs all the way down to the end where the bathroom is. The bathroom has been studded. It's not completed, but it has been kind of studded in. So for the guys that was worried about that, we did do this OSB and wrapped it. All right, and then there's been a little bit of painting done on this wall, not a lot, and some of the electrical has been started down there. It's not finished. None of this is finished, but we got some electrical there. There's going to be another one over here, and there should be another one down at the other end as well. There's also going to be some air lines. You know, there's going to be an air line up top there dropped in. Okay, there's the breaker box right there that all the 110 voltage will be hooked to for out here, light switch and so forth. Okay, so it's not done. Everything is still in the middle of being done, but nothing is complete. So hopefully in another week I'll have a little bit more progress to share with you, but I'm very optimistic at this point. So we'll just cross our fingers and hope we get some more work done soon. I'm working on the taper attachment of the Monarch, getting it set up to cut a 3 inches per foot taper. That's what it is, 3 inches per foot. Getting it set up, and I'm getting it tweaked in. I think I got it where I want it now, and I'm just showing you my setup to kind of verify the movement, and I'll take you over there and kind of show you the badge again, or the plate that is engraved with the angled and the taper per foot. And it's got the magnifying glass there that you can look through to line it up like it's supposed to be. But over here on this side, on the carriage operating side, I've got a couple indicators set up, and we're going to move this thing down to see if it's if your cross slide is moving the proper amount. So it's a 3 inch per foot taper that we've got to cut, and that actually equates to a 1/4 inch per inch of travel. So that should be per side, or if you go per side, that's going to be 1/8 or 0.125 inches for every 1 inch of travel. So that's what I'm setting up. So over here we've got our indicators set up. I've got this one on 0. I've already got the backlash eliminated from the screw. You know, we got it in our forward moving direction. We got it 0 here, we got it 0 there. So this indicator should clock 0.125 whenever I hit 1 inch travel on this indicator. So we're going to go ahead and do that, and I'll just kind of count it out as I go. Got both of them lined up dead on 0. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, there's exactly 1 inch of travel, and we have moved exactly 125 thousandths on this dial right there. So it should be per side 1/4 inch of taper per inch right there. Back earlier in the year, I did a couple tapered, well actually no, it was just one, I'm sorry. I did a job for John Saunders NYC CNC, and I posted those videos on the channel, and we talked about the taper attachment. We cut that tapered shaft, and then I did a follow-up video on how this works. So I'll post a card to that. So if you haven't seen that, you might want to check it out. I kind of explain how this taper attachment works. But this is a really nice taper attachment on these Monarchs. It's got this plate that's bolted down that has the graduations made into it, and then you have this magnifying glass with a line down the center that you can line up on the line. So the first row gives you taper per foot. You can just see the foot word right there. So that's taper per foot. And then the bottom row is degrees, angle. So I've got it set on 3 inches, and the angle for that is 7 degrees and 15 minutes, I believe. And it looks like that's where the line is. There's not a graduation for the 15, but it's just past the 7. And I know you can't see that on the GoPro. This magnifying glass is a little bit dirty underneath it, and I have a really hard time of trying to get that thing clean. It needs to be removed, so you'd have to take this whole thing off to clean that. There's my attempt to try to get you a better shot of it. Lined up on the 3. The 3 is next to the main line there. All right, so it should be 3 inches per foot of taper. And just to kind of quickly summarize, how this works is your cross feed screw through the cross slide here is attached to this block. This block runs through the channel. So as in telescoping, that's how it can move. On this other end, the lead screw is telescoping. So as you crank the carriage down, this block here is gonna follow this channel, and it's gonna move your cross slide in or out, whichever direction you're going. So that's how that works. Kind of the quick overview anyway. I got the 4-jaw adjusted. Here's our gear that we're going to be chucking up. We're going to chuck the hub side here. Now we'll point out there's kind of a small radius in this corner right here, and these jaws are pretty square to the end, so I'm not going to be able to push it all the way up against there and chuck it, because it's going to try to push out on that radius a little bit. So I'm just going to have to come off of it a little bit. We won't worry about squaring it up directly against the face of the jaws. All right, you see we got some run out there. What we'll do is go ahead and make sure our face is running square. And you can see there we're running out a little bit, so we'll go ahead and bump that. We'll bump that around. All right, that's 1 thou. Alright, we got her pretty close there. So what we'll do is that this hole should be machine true. It should all be concentric. So we'll indicate this hole right there. I'm going to go get my hole, the ID indicating attachment, and we'll be right back. So I've shown this several times throughout the years in my videos. This is a Starrett number 670, and it's a ID hole attachment that goes on here. It's very quick and easy and handy for indicating the inside of a hole. You can also use it to get in behind something if you need to. But I was going to point out, I have one more here. This is the Brown and Sharp. It's the same thing. It's a hole attachment. Basically the same thing as a Starrett. The only difference is the little finger screw is on the opposite side, and they milled a flat here where the indicator touches it, but it's the same thing. Every now and then I use that one. Both of them work excellent. Stick it in the bore and give it a little preload. Try to get it centered up, you know, the needle there. So after I get this, so it's about 1/8 of an inch out, like I always show, I just do a little at a time. I'm in no big hurry. And what we're going to do is loosen those highs and tighten up the lows. If you loosen them up too much to try to move it halfway, you risk the thing falling out on you or tilting. There was a loose jaw there, so I was able to snug that up and get it really close. Right, and then below this fine adjust bottom, and you can move that dial, that needle around. So I'm sitting there looking at it, looking that way up there where the zero is the easiest place to make sure that we got it running true. I don't know, it looks like maybe 2/10. So we'll go back to the face now, and we may have to move it. Yep, see, we had to move it quite a bit, so it's going to shift around on you on them jaws a little bit. What do you think? Good enough? All right, and we're going to go back to the bore. Yes, it would be easier to have 2 indicators, but I only have 1 dial indicator set up on the Noga. The other Nogas I have set up with like a test indicator. So I just, like I said before, I like using the dial. I should have 2 of them. I don't. I'm going to tighten that low. It's only a few thousandths, so you can usually get it to move that little bit by just snugging the low. Or if you're on the OD, it would be the high. All right, we're within a thou. Tenths. All right. So we're going to leave it at that. I'm going to go back to the face. I'm going to check it. I'm going to make sure that both the face and the bore are running true before we carry on with the machining. We got the gear running nice and true. I've got a bar set up on center. We're ready to touch off and start making our cuts. I haven't ever used this bar before. That's one I picked up at Moultrie last year. Looks like it takes like a CCMT type of insert. We'll see how it does. I got a 1/4 inch of clearance, And actually looking at it now, I think I'm going to have to move this tool post down some. I'm going to have to move it down because I failed to look down here. The side of the compound is sticking out further than the side of the tool block right here. So I need to loosen this nut and slide this thing over so that this is sticking out further than the compound. All right, we got this reset now. Just loosened that, slid it down, squared it up against the face of the gear, and we are ready to go. I'm using the compound to, I'm going to touch the tool. All right, there we go. I'm going to run this back. Let's go 100 thou. Oh, that's doing pretty nice, man. I was expecting a little chatter, actually. All right, so we run it back. Then we crank our cross slide back. I'll show you that here in just a minute. And then go back in. If you run it in and then feed back, then you're going to be eliminating your backlash while you're trying to make the cut. Crank it back. That was our second cut, so now we're going to do one more. I'm just taking 100 thou on the dial, and then we go back in. So before I go any further with this, I figured we'd go ahead and talk about some numbers on where we're going to be boring this to. So I got a drawing right here that was given to me, a hand sketch. We have our knowns on here, which is a 3" per foot taper. That's our main dimension, and then we're going to work off the large diameter. They got that wrote here, 2.180 should be the large end, and then they wrote the small end down there. But we also have a length right here. Now they put 3.520 length through bore, but that might be on the existing one. We're going to measure this one and make sure it's 3.5. So we finally get to use our hub mic right here, the Michitoya 3 to 4 inch hub mic. This is a perfect job to use this. All right, so I'm getting, that's 3 inches, 503 thousandths is what that is. I'm gonna call that 3.5. So this is a book that I use oftentimes, Machinist Ready Reference, and there's a page in here, rules for figuring tapers, and it's very handy. And what I wanted to do was take these notes and kind of compare what I get to what they got down here for the small end. And what I got is 1.305 working off of a 3.500 hub length. That's what we're going to consider at 3.5. So right in here it'll tell you the given large diameter and length of taper and taper per foot. So we know that our taper per foot is 3 inches. Divide taper foot by 12, multiply by length of taper, then subtract the result from the large diameter. So that's what I did right here. 3 divided by 12 gives you a 1/4 inch. 1/4 inch times 3.5 is 0.875. Subtract that from 2.180, which is our large diameter, and that gives you 1.305 on the small end down here. So they've got 1.295 written on there, and I just imagine that somebody was using some calipers in an old part, and that's just the measurement that they got. So if we're on our correct 3 inches per foot taper, this dimension right here is not very critical as long as we hit our large size where it needs to be, right around the 2.180, because if you make this too big or too small, then it's going to make this too big or too small. It's going to fit in a different place on the shaft. So we're just going to try to hit this big end right at 2.180 as close as we can and let her go from there. And of course we'll try to get us a nice surface finish through there, nice and smooth. All right, so I just wanted to point that out. Handy little book that I use sometimes right here. This is another one that I go to every now and then. The Old Machinist Practical Guide. It's got some handy info in there every now and then. Down to about 60 thou that I got to take out of it, and so I'm going to back off to 20 thousandths depth of cut. I sped it up to 530 and reduced the feed rate to it's actually 4.5 thousandths. I want to do a test cut to see how this insert's going to do, and the reason why is because, you know, this is a new insert for me and it's got a large nose radius on it, so I want to see what kind of finish it'll give. After that cut, we'll look at it and see how smooth it is. I do have a 1-inch insert bar that I can switch to as well. It takes a different kind of insert. That was our first little finish pass through there. It might not look too bad, but it's a little more rough than what I think it should be. And then I'm going to swap out some tooling and see if I can improve that finish. So I swapped it out to a 1-inch bar. This is a Trigon insert, ones that I use every day. We'll see how it does. I think I got her dialed in the way I want it. It's got a nice smooth bore there to it. And I just measured it. I'm at 2 inches 150 on the large size right now, so we got 30 thousandths to come out, and I'm going to go for it. Back off so I don't drag any. All right, it looks good. I think I'm right where I want to be. I want to break that edge ever so lightly. I'm going to use this Noga tool to do that. Just like that. All right. All right, we're gonna hit that board just lightly, and this 1/4 inch rod, just a homemade flapper with a little bit of emery wrapped around it. I just want to hit it a little bit, just to try to knock any of that fuzz off the board in there. Not gonna hit it much, if the paper will cooperate. Oh yeah. Yep. That's perfect. Just like that. All right, there's our gear finished up in the lathe. Turned out pretty good. Got a nice smooth bore. We'll go ahead and do a check on this and see about where we finished it at. I got 307, 307 and a half right there. All right, 307, it's about the biggest I got. I did very lightly try to scrape that edge off there. So I think we hit very close to our mark, our 1.305 on our small diameter right there. So I actually have 2 of these to do. There's one more that's identical, so no need showing the same thing again. I'm gonna go ahead and do the other one, and then after that I'm gonna make a broach plug for it. So what I'll have to do is take a piece of stock, and we'll have to flip the taper attachment to the other side. So instead of boring a taper, we'll be turning a taper to match this, and use that to make a broach plug for a keyway brooch. That'll come up in probably next episode or so. So hopefully you enjoyed, and we'll see you on the next one. All right, so I had to break out my orange gloves for this box right here, but we got a really cool viewer mail box that came in, and this is from Bob Alfred. He is from Whitmore, Michigan. So Bob had emailed me after the video at the SNS Space Center, and during that video I had shown where they had a tile on display off the space shuttle. And in the video I had mentioned that it would be cool to have one of those to use around the shop, but I called it a heat conductor, when in fact it's not a heat conductor. It's that tile is what would be known as a heat insulator, as Bob corrected me, which he's right about that. I called it out wrong, but he had emailed me and said that he had some of these tiles that he would send me if I needed some. So what these are, I've got his email pulled up right here. This is graphite foam board with a graphite foil face, and they're used in a hot zone of a vacuum furnace, and it's some stuff that he does, I guess, for a living there. He lines those furnaces up with this stuff, but he said that he had some of these that he would send me, so I told him that would be great, and we can use these over on the welding table whenever we have to do some brazing or some soldering, or if we got a part that we need to do some preheat on, or if you got, say we got a sleeve that we need to shrink onto a shaft, you can set your parts on something like this and do your heat. And this type of material insulates the heat from being drawn through into like the table, where if you just set it on another metal table, that's drawing the heat out of your part. So this stuff right here hopefully will work pretty good. I've always used fire brick. That's what Dad always had, was fire brick. Still got them under the table, and that's what I've always used. But these could be very handy for many things. So we'll find out. I'd like to put them to the test and see how they do. In his email, he also said that he had given these to a plumber, and they've used them for when they had to do some soldering of some copper next to a drywall. But they would stack these things in there next to the drywall and have to do their soldering, and no problem with the heat going and affecting the drywall there in the paint. So could be very useful around here. So Bob, thank you very much. I can't wait to try them out over there underneath the torch. He also threw in some extras. We got some high performance taps, some 1/4-20s, and some different cutters, just different drill bits and things like that. A couple spanner wrenches, and then this expanding mandrel. I'm not exactly sure what this thing is used for. I've never seen one up close before. So Bob, you can let me know what exact use that could be for right there. So anyway, I just wanted to share that box with you right there. Thank you very much, Bob. I appreciate it. Another heavy box of high-speed tooling came in this week, and all this stuff right here is from Sam Robertson. He's from Hollywood, California. He had acquired a bunch of high-speed tooling from an uncle that has a shop in Ohio quite a while back, and he says this is all the tooling that he hasn't been able to use because he only holds up to 1-inch shank. And all of these right here are 1.25-inch shank or even larger than that. We've got a couple of the big end mills right here. That's a 2-inch shank, and you know, we can use this kind of stuff over here on the K&T. They all have been reground, so they're not on a nominal size. They're just regrinds, but great for any kind of general milling that you have to do. So Sam, I really appreciate that. These are going to go in the drawer with the other good cutters over there, and I'm sure I can put them to use. Okay. Thank you very much. All right, shiny tube, and then you got electrical tape there. And what are we doing?
That's called emissivity. It's shiny surfaces versus dark surfaces. They confuse these high-tech guns right here.
Yeah.
So you see the temperature is 132 degrees, and when you slide it over to that shiny surface, it drops down to 105. So basically 20-something degrees difference just from that shiny surface versus the dark surface.
This is a gearbox shaft that I recently machined at work, and I'm sharing the pictures with you of the lathe work that I did and it being completed. And I've got a couple clips that we're going to share here in just a second. One is showing the total indicated run out before I cut the keyways, and then the second video is going to be after I mill the keyways. I had somebody ask me if I check them, because I showed that video on Instagram of checking the TIR, and then so I'd made another video showing the TIR after the keyways were milled into the shaft. So here's our first video, just showing you that the indicator is touching, and this was before I took it out of the machine, getting both ends finished out. You can just barely see that needle moving. It just worked out great, and most of these shafts always turn out that way. That is some of that heat treated 4140. It machines nice, it finishes nice, and it's a great material to make a high strength shaft out of. So I'll show you all the journals, and all the run out is pretty much identical everywhere I tested at. And some of these spots I won't be able to check it again with the indicator because keyways will be there, but we'll show you here on our next video. So after milling the keyways, I brought it back to the lathe, but this time I set it up between centers, and we're gonna do the same test. Now you can see a little bit of wiggle on that indicator, not much. We got maybe a 0.5 in some places there. So it's looking pretty good, right? Sometimes milling a keyway can make that shaft move a little bit, but I found that in most cases with this 4140, it never gives me a problem. And one final clip for you this week is another shaft that I had to do some tool post grinding on. That's a bearing journal that was worn down. We sent it out. We had it hard chrome plated, so it built up with chrome. And I set my tool post grinder up, and I'm grinding it back to size. So I know I've got a lot of requests to show this on my channel, so I hope that I can bring you a good video in the future here of showing the tool post grinder in action.